schedule the last couple of weeks because it's the holidays and I haven't had a whole lot of time. But I am back on today, found a free hour, so I figured I would jump in and do a couple of problems. Just a heads up, I'm going to be trying something new. Supposedly, you can monitor your streaming dashboard from a mobile device if you have the Twitch app installed. So I'm going to give that a shot and just see if it's a better, easier way to watch chat or if there's anything else that comes there. So if you see me get distracted or I'm looking at a Google Pixel at all, you'll know why. So today I've got about 4 problems lined up, kind of like normal. We'll always see how far we get through them. I got a couple or one that I'm actually not sure what data structure problem set category this one falls into, the first one, but we'll find out. And then after that, we're going to look at linked lists and then do some binary tree stuff. So without further ado, let's go ahead and get started. Okay, and as usual, I'm going to up the size of my screen quite a bit. Taking a look at the preview. That's not too bad, so it looks to me like it would be legible. Um, if you're in the chat and you want it bigger or smaller, feel free to ping me and let me know. And I forgot to mention this. I am back on Leetcode today. I ran through a lot of the hacker rank problems that I wanted to. There were some specific problem sets on there I wanted to get to. And now that I've done that, I'm going to jump back onto Leetcode. I prefer the interface there for the features they've got. So let's go ahead and get started. This problem starts. You are climbing a staircase. It takes n steps to reach the stop. Each time, you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? You're climbing a staircase. It takes n steps to reach the top. Each time, you can either climb 1 or 2 steps. How many distinct ways can you climb to the top? Interesting. Okay. So if n is 2, climb it in 2 ways, 1 and 1 or 1 and 2. N is 3, climb it in 1 and 1, 1, 2, and 2, 1. One is always between 5. So this is interesting. So there's obviously a pretty trivial force solution, but I'm trying to think if there's something a little bit more clever that we can. So there might be something, because this feels like some kind of a combinatoric problem where got a set, don't care about set order. Maybe it's not a combinatorics problem because it's been a while since I looked at anything combinatorics related. Let me think through this. So at 3, you've got 3 ways. At 2, you've got 1. What are your options at when you've got 4? So at 4, I can do +1 plus 1, 2 plus 1 plus 1. I can +2. I think that's it because I can't do 2 plus 2. Uh, Interesting. So what's the trick here? Wonder if it matters if you're even or odd. So let's do 5. So at 5, I can do this one, 2, or 5. 5 there. I can do 2 plus 1 plus 1 plus 1. And I can do 2 plus 2 plus 1. Feels like I should have another option here. 1, 2, 5. I can do 2. 2, 2 plus 2. A little surprised that it's the same as 3. Oh, order does matter. Okay, so here we've got 1 and 2, and then 2 and 1. Okay, so order does matter. So in fact, for 4, I do plus 2 plus 1, and I can do 1 plus 1 is 2. So now I'm trying to think of what a possible solution would be here. That's not just forcing all different possible combinations. Um, and yeah, cool. So my stream manager popped up, and like I've got a way to update information. I can change some settings, like for my notifications and such. I can see my chat. So actually not terrible, aside from not being able to see overlay. Not bad. But back to our problem. Okay, so my first question is if I can solve this recursively. I don't know that I can, or not sure yet, because for 3, how would I know the unique solutions I've got? Or really what I should be asking is, does 2 build on, or does 3 build on 2? Because for 3, I've got this step. For 3, I've got this unique step, and then I've got just plus 2, but neither of those show up in this solution. So I don't know that I can solve this recursively easily. See if there's anything strange. Um, so does it have anything with? Well, let me finish out 4 just to make sure that I understand. 1, 4. I've got 2. It's 2. Let's move it down. Yeah. So here I've got 1 plus 2. And what other combinations do I have? I do have just 2 plus 2, which gives me. And is there anywhere else I could inject option? I don't think so. So this is 5. And then let's just do 5. And I think that's as far as I want to go, because after that, the combinations are going to get pretty large. So here I could do 1 plus 2 plus 1 plus 1. I could do plus 1, 2 plus 1. Do 1 plus 1 plus 1, 2. And I could do 2, 2, actually number 6. And then number 7, I could do 2 plus 1, 8. I could do 2 plus 2. I think that that's all my unique combinations. Is that just 5 factorial? So is this, so this is a summed permutation because order matters, so it's not a set list. and I need to know all of the different ways that I could combine those to get up to. I'm struggling with this where to get started, so let me think that through. So my first thought is I could take the number is how many ones I have, and then if the size of this list is even, then I know I can um, march through and convert two ones to a two, and that's a way that I could get all of my different combinations of twos. I could walk through and just take two elements at a time and two, and that would give me all of the possible different elements. Um, and then from there, I'm trying to think of a way that I could find the permutations, but um, well, and that gets tricky because order matters for type of element, but not for the number of them. So I'm assuming, like, it doesn't matter which here doesn't matter. It's just if you're placing a two that. So and it's not like the previous problem really doesn't lend itself to, as far as I can tell, I don't think it lends itself to. Maybe it does. So here we've got two, got five, eight, because at each step, add one new possibility. So I'm still kind of trying to think through if there is a way to do this recursively. This is the Fibonacci sequence. So first one is, actually it might be, or and no, I don't think it's the Fibonacci sequence. Hi, hey, Vivax, as if I'm saying your name wrong, but welcome. I'm working through a climbing stairs problem, and right now I'm trying to just decide what category problem this fits into. And I'm noticing that it feels a lot like the Fibonacci sequence, where the fifth number is 8. So I'm wondering if there's a pretty formulaic way. Yeah, same. I know I did something like this in college, um, or it feels very familiar. And I'm starting to wonder if it's like an n minus 1 plus n minus 2 typed problem because, uh, oh, and that doesn't make sense either. That's what I'm kind of coming back to is there's a pretty obvious, or not obvious, but there's a brute force solution here where you generate all the possible combinations of one, twos, and then you figure out how many different options you've got there. But I'm trying to see if there's something a little bit more clever I can do. I'm trying to avoid Googling this one because 3 is 3 and 2 is 2, but then 4, I believe, is 5, which actually is the answer for n minus 1 and n minus 2. 5 is 8, which is n minus 1, and n minus 2. So this might be the Fibonacci sequence from a different starting point with this. So let's try that actually. I don't know that that's right, um, but I'm kind of wondering if this is a Fibonacci sequence just from a different start point. So without taking the time to do the math proof, I think I can hammer out a function for that pretty quickly, and then we can just test it on a few constraints and see what we get, or even just have Leetcode test it for us. So and you're my only watcher. I'll keep chatting with you, Vivax or Vivax, and you want me to pronounce that a different way. But I'm going to do this with memoization. So this will be n to answer. Then our base cases will be if n is equal to 2, turn 2. If n is equal to 3. I'm also doing this in Java, by the way, which you can probably see, but just the language I'm most familiar with. N is equal to 3. We're going to return 3 if uh, n to answer dot key n turn n to answer dot n. Okay, and at this point we know that we haven't found so we've gotten past all of our base cases, so we need to make this one simpler. So we're going to go final int answer is equal to climb helper at n1 plus climber at n2, and then we are going to answer dot put answer answer. Okay, so if I'm right and it's just the Fibonacci sequence starting from a different base case, then we'll try that. If that's not the answer, then I might Google this because it feels very similar to kind of a factorial, um, feels like a combinatorics problem of some kind. And I'll be honest, I skipped combinatorics in college and in grad school. So it may not be the best reference, that kind of thing. Let's give it a shot. Final map to integer. The other reason I'm wondering that is marked as an easy in Leetcode, where I can see, but yeah, it's marked as so being like a really deep math problem doesn't me, but who knows? Maybe Leetcode thinks math is easy. Okay, so we're going to return helper at n. That a shot. That'd be applied to the type. Oh, I got to pass in my n to answer. Okay, so it works for 2. Let's try it for. So let's try it for. And this is where we get a little bit dicier, because here's where we're tempted to run my code soon. Probably should just subscribe to Leetcode. Okay, so 4 works. Try it for 5. Or actually, let's go out a little bit. Let's go to 7 and just see if 7 matches as well. Okay. Okay, so that actually looks pretty promising. So if 7 matches up, that's far enough out with enough different permutations that I wouldn't expect it to. Dumb luck that it worked. So let's try running more test cases. Oh, okay, and they only go to 3 and 2. So we'll just submit it and see what happens. Um, shot Stack Overflow. Okay. So apparently they're passing in a large enough number that can't do this recursively. But to me, it looks like the algorithm is on the right track. So I think I just need to convert this from being recursive, being iterative. It shouldn't be really all that bad. Let's leave our climb helper, our recursive solution alone. Let's flip this from being recursive to iterative. And I'm okay making that kind of a long method signature because I should never have to put more than once. And here I can just create my own end to answer because I don't that. Or yeah, I don't need to worry about passing it in function and having an original version. Kind of getting over a cold, which is why I raspy. Okay, so while true, I think is going to be our easiest way to iterate this. Um, uh, no, actually, I think we'll do while need an iterator here. Int I is equal to I is equal to 3. 3. I already know what those two are, so let me prime the with so 2, 2, 3, and n to answer 3. So while it's 4, and then we'll go I is less than n, because at that point we know that we've got, at this point I know that I've run n and I don't need to keep iterating. Okay, so I think how we want to do this. So at this point I know that I'm, instead of starting at the top, I'm recursing from I already, which I think is going to make, I think it's going to make this a little bit, or the array or the hash map a little bit less useful, but I'll keep it for now. But I don't need to check if I've already found those answers. I know that I know that I'm going to find them. So here, what I want to do is n to answer put I, and then my answer is n to answer dot get I minus 1 plus n to answer dot get I minus 2. So I'm going to just automatically create my entry for I, and then I'm going to do it by accessing my hash map and go back to. Then when this loop finishes, I know that I've done n. I should just be able to return n to answer dot get at n, and that should do the trick. So comment this out just so we're not using memory than we need to, and we're just going to return. No, I want it to be iterative climb helper, not climb iterative climb helper. Give that a shot just on some test case. Oh, no attention to my to my folly. So actually, I wonder if this should just be a. Then I don't have to worry about doing that iterator inside of there. So let's go for I equals or I less than n, I plus plus, and then we can take out this extra increment. and then we're going to run from 4 with 2 base cases. We would or all the way up to n, and then I should be able to just return n at this point. So let's try that. Exception. Oh, okay. So I guess there is a case. How did I get a null point? I should have run. Let's just n. Oh, I should probably do less than or equal to. Yeah, because I want to actually run n. Okay, okay, yeah. Wrong. Expected 21, my output. See this correctly? I did not. 2 should be not 3. Go. Okay, so 7 gives me 1. Try. Just gonna comment that out. Just change some. It seems to be that a little bit better. So I can't do. Okay, that looks correct. So go ahead and submit. And it's a pretty large number. So unless they were doing like bigger and it freaked out, then I think that should be able to without getting this optimized. Executed input. Okay. Uh, so I guess this is an edge case I really need to handle. And answer dot put 1 is going to be 1. There's one step you can do that, and then if I'm past 1, I'll just get it out of this put. I bet I need to handle answer dot put 0 would be my assumption. So if there's steps, then I have no getting onto the steps. And let's just see if we can handle that correctly. We do uh, and that's honestly one of the really great things about code is that they okay, so I know it'll have a value. That's one of the great things about Leetcode. They push you to handle those really unique edge cases. And if you're writing code for a job, this kind of stuff sincerely matters because you never predict. Let's try that. Nice. Okay. Memory usage was 35 megabytes, less than 97%, and we were fast, which is fantastic. There's not a whole lot here to optimize. One of my favorite parts of streaming, though, getting the right answer and then seeing make it run a little bit better or a little bit faster. So let's, because I think this could be converted in array probably easily. So let's try it. If we instead of a hash map, if we just a really big, I don't know how, or no, not necessarily. We just need it to be as big as n, or n or n plus n plus 1. Got space for n. A size n. Can't do but we indexing now. I don't know if this is actually going to bias much in terms of, but it should be slightly more efficient. Behind the scenes, create a hash map. Java allocates some arbitrary amount of memory, trying to give you enough to grow in. Where data structure its expansions behind, but that also might um, create some extra over. Don't necessarily. Again, the goal is fast and efficient as we can. I and at this is actually going to be and at and try it. Bad, bad. Okay. So okay, so I know I'm always going to have one. I have these first two cases, and I think I might just back up my thing to start it because two extra iterations of this would not be a big deal. But here I know that I've always got options. I know that I'm none of no, that won't work. Oh, that's not going to work. I think I just need to handle edge case, edge case. So if uh, one, and I don't really store these. I could do some fancy information, but I don't going to bother. Now I should know that I'm always got enough. If I get past 2, then I think I've got another problem here. So ugly as this is going to get, so n is equal to 2. So now I've handled these edge cases, a couple extra variable sets in those cases, but fine. So now if I do 2, that should. Okay. Now let's just try submitting and get expected. And here I want to start at 4 again. I don't want to calculate with anything less than my again. Ooh, interesting. Okay. The memory usage actually went up by quite a bit, which is not what I expected. Oh no. Or a little bit, yeah. 100K. That is, but well, no, I can't think of why I would be quite a bit bigger. So there, it's interesting because some sort of common intuition memory footprint actually the opposite effect where I hash map to an array. Um, but at any rate, problem is solved. So let's jump to next one. And it looks like I might have somebody else in the chat. So thanks for jumping in. Appreciate you hanging out. I'm going to be doing another leak problem here this cycle. Feel free to visual big enough or not big enough. Kind of a chat. I don't know. But so let me know if you can see the problem that I'm working on. If you need anything moved or need it to be bigger or smaller. And this one is going to be a link cycle. Thank you for the follow-up, by the way, Vivax or Vivax. Pronounce your name. Appreciate it. Would love it if you could come and hang out and do some So without further ado, we'll dive into this one. For a linked list cycle, and given head of a linked, determine if the cycle some node again by continue next pauses you next of that's for like big languages where like because I don't think I need to worry about Java. Which, again, if you hadn't noticed, Java turn true cycle. Okay, add a couple examples. Two cycle fourth. Oh, constant math. That part shouldn't be a problem. So to me, this feels like a pretty straight solution. Should be able to iterate down the like track of it and then see the node that we're getting has altered. So cycle for head set this node. Going to keep track of our the nodes visited. That is what we're name that node. So our base case is going to be if null false. So if we've hit the end of the list and haven't already returned, then we false that we're good to go. Else, if visited contains node. So if we pick a node and I've already visited it, then I know I have a cycle. And else down reverse down. Actually, I'm going to take this because I don't want Java. No, that should be fine. I should be able to do it. I was worried that Java would tell me that I didn't have a return statement in this method, but if it's in it, I should see it. So otherwise, I'm going to cycle. Yeah, so add turn as next. Okay, let's give it a shot. Just I need that, which actually line here. Head that snow. Okay, let's try it. Okay, so the correct. So we'll go ahead and submit it. Chance I'm gonna hit a Stack Over because oh no, okay. Faster than sent. 2% way that we can function. And also I was able to quickly. I've done a number of problems and they all kind of follow a pattern. Some are good. So you're doing an interview prep, you're trying to get ready for a job interview. It's really helpful to something that you with, but it is fun, and it's always good to stretch those muscles if you can hit the. But for now, let's see if we can figure out why this was. My first thought is to switch this from being a uh, um, well, I think two things. So value always rates. So I'm checking. I'm trying to understand if this is every node. Okay, oh, and then maybe I missed it because turn or it's asking if I can solve constant memory, and I'm definitely not. I'm solving this in n memory, 2n, adding tree every item. About this is and okay. So if I can destructively modify the, then I think and n value. Okay, so here's why I'm pausing and kind of laughing. So it's so with a concept of immutability, to not change anything that you're handed, to leave every data structure, every piece of data you're handed alone, and just operate on what you've already got, or create copies. Eh, well, thanks for letting me know my audio is cutting out. I don't know if you're still here or not, but greatly appreciated. I have a few things that I need to do to get my stream set up a little bit better. I need a better camera. I need a better mic, but I'm not sure if it's like my system performance that's making it cut out, or if it's just like my mic cable got chewed up a while back. But I'll try and figure that out. Um, so at any rate, enjoy the movie. Great chatting with you, and thanks for jumping on. Um, so usually you don't want to destructively modify anything that you're handed, but I think in this case I can, and I think I can use that to my advantage. So I'm gonna change. We're actually gonna leave this commented out. So here we're gonna have public and has cycle. It's gonna have list node. Say if node dot val integer dot max value, then return else if or really if node null turn else node, or really this should be our first case, shouldn't it? Else node dot val gets integer dot max value, and we're to and we're going to recurse. So has cycle for next. So here I'm destructively modifying the list, a marker of Ben, and then if I make it all the way through the list without ever finding a node.max value, then I'm good. If I do find no.max value, then I found a cycle. Let's try that. But I think I need to update my method, not find a valid method that way. Oh, okay, so that was true. Okay, on a few more, I've attempted soon. So let's just submit it and we'll see what happens. Okay, so now my runtime is blazingly fast, but my memory usage is still a little high. So I'm wondering if that's the recursive activity here. So let me let me try and convert this to be iterative instead of recursive. So I need a temporary node, temp head, and then uh, temp not null. Recurse. Get through all of this. We're going to false, not recurse, but we're going to iterate. And then if temp is not null, uh, if temp value into x value else we want to set temp.val to integer.max value, and we want temp to get next. That should work. So while temp is not null, if value is max value, true, otherwise leave a marker and jump to the next node. Get through all of that and go ahead. Let's try that. Okay, true. Let's submit it. Let's see if this runtime is better. Okay, that's a little bit better. Now we're better memory than 72%. As if there's something else there. One thing I can think of is I don't actually need to keep track of head anywhere. I don't use that after I've used, right? I don't use that after I've set this value. So let's temp. Let's just say head, and head, head, head. So I'm destructively modifying the list and I'm losing my pointer to the head that got passed in. Let's try that. And that does for memory usage. Can't imagine it would be a lot, but nope. Okay, well, we'll take that. And I've probably got 10-ish minutes left. So I will jump to actually, I'm going to take the feedback from Vivax, and take the time to take a look at my audio. So that's all the problems I'm going to do today. Greatly appreciate everybody dropping by and hanging out to do some coding challenges. I will hopefully have a schedule sometime in the new year, but until then, I'll just kind of be popping in and out as I can to time as I go. So have a great day and happy coding. Bye.